Imagine a single solar storm so powerful it could bring an abrupt end to space travel as we know it. This isn't science fiction. It's a very real risk scientists are warning about today. Before we dive deeper, make sure to subscribe for more insightful explorations of the science shaping our future. Our modern reliance on satellite networks is staggering. Thousands of satellites orbit Earth in what's called low Earth orbit, or LEO, forming vast mega constellations that power everything from global internet to weather forecasting. But according to recent research, this system resembles a precarious house of cards, delicately balanced and alarmingly vulnerable. Here's the startling fact. Across all these mega constellations, 2 satellites come within just 1 kilometer of each other every 22 seconds. For Starlink alone, this close encounter happens every 11 minutes. To avoid collisions, each satellite performs dozens of evasive maneuvers annually. Starlink satellites average 41 such moves every year. On the surface, this might sound like a well-managed, efficient setup. But engineers know the trouble lies in rare extreme events. The edge cases where systems tend to fail. One such edge case is the solar storm. These are bursts of charged particles and radiation from the sun that can wreak havoc on satellites. Solar storms impact satellites in 2 major ways. First, they heat Earth's upper atmosphere, increasing atmospheric drag on satellites. This drag changes their orbits unpredictably and forces satellites to burn extra fuel to maintain position or avoid collisions. In the massive storm of May 2024, known as the Gannon storm, over half of all LEO satellites had to use fuel just to dodge potential crashes. Second, and potentially far more damaging, solar storms can disrupt the satellite's navigation and communication systems. Without these systems, satellites can't receive commands to adjust their orbits. Combine that loss of control with the increased atmospheric drag, and you have a recipe for disaster. A cascade of collisions, too rapid to manage. This scenario is the essence of what's known as Kessler syndrome. In this state, a dense cloud of debris surrounds Earth, making it nearly impossible to launch or operate satellites without them being destroyed by debris collisions. But Kessler syndrome usually unfolds over decades. The new research introduces a more immediate measure called the Collision Realization and Significant Harm, or crash clock. Their calculations show that by June 2025, if satellite operators suddenly lost the ability to command their satellites, say due to a solar storm, catastrophic collisions would likely begin within just 2.8 days. To put this in perspective, before the mega constellation boom, that window was over 120 days. Our satellite environment is so crowded that losing control for even 1 day carries a 30% chance of triggering a collision event severe enough to start the long-term debris cascade of Kessler syndrome. What makes this even more concerning is how little warning we get before solar storms hit. Usually just a day or 2. And there's no way to prevent the storm itself. The best we can do is attempt to shield satellites and prepare for rapid response. But the dynamic conditions introduced by solar storms demand constant, real-time control to keep satellites safely separated. If that control is lost, the research warns, the satellite system could collapse like a house of cards in mere days. This threat isn't hypothetical. The Gannon storm of 2024 was the strongest in decades, yet we know of even more powerful events. The Carrington event of 1859, for example, was the largest solar storm ever recorded. If a storm of that magnitude struck today, it could disable satellite control systems for weeks or longer, devastating our satellite infrastructure. Such an event would effectively ground humanity's ability to use space-based technology for the foreseeable future. No satellite navigation, no global communications, no remote sensing, and no new launches. The consequences would ripple across every facet of modern life. This poses a critical question. How do we balance the incredible benefits mega constellations offer against the very real risk they face from solar storms and the cascading hazards their failure could trigger? The research doesn't offer simple answers, but it does provide a clearer picture of the stakes involved. Understanding this vulnerability is essential for making informed decisions about how we manage and protect our satellite networks going forward. Space has always been a challenging environment, but the rapid growth of satellite megaconstellations has introduced new complexities and new risks. A single solar storm could unravel years of progress in just days, reminding us how fragile our high-tech infrastructure truly is. If you found this exploration insightful, please subscribe for more thoughtful science stories that help us understand the world and universe we live in. Staying informed is the first step towards safeguarding our future in space.